Okay, we're going to continue taking a look at some of the methods of science, and we've been looking at measurement as a method. And one of the things about measurement is if we're going to be taking a measurement in the laboratory as part of an experiment to test a hypothesis, we want those measurements to be both accurate and precise. Now, we have a tendency to think that accuracy and precision are the same thing, but the reality is that accuracy and precision are two very separate things, and they measure two very different quantities, and we're going to take a look at that now. Precision is defined as a number that indicates the consistency of a set of measurements. So I want to take a person's temperature. I know a person's temperature should be 98.6 degrees Fahrenheit. That's the average temperature for humans. And when I take the temperature, the first time I take it, I get 98.6, what I was expecting. The next time I get a few minutes later, I take it and I get 104.7. And then a few minutes later, I get 92.7. And then a few minutes later I get 72.9. So these numbers are not very close at all. They're not very consistent. So I'm not being very precise. Let me give you an example of being very precise. If I want to hit a target, and the target area that I want to hit is here, and I line up my gun, okay, so now what I've done is I have hit my target, but I haven't hit my target where I wanted to, but I was being very precise at where I was hitting the target. Notice I'm being very consistent. It might be wrong, but it's consistently wrong. Now, sometimes in the laboratory, when we are getting a number and it's consistently wrong, that's usually the kind of error that we call a systematic error. I'm using the thermometer wrong, for example, and it's a thermometer that I'm supposed to place in a human's ear if I'm taking a human temperature, and I'm putting it under their tongue instead. And so I'm getting these numbers that are crazy, and they're not, you know, they're consistent, but they're consistently low or consistently high. They're precise, but they're not very accurate. That's precision. Now, accuracy is a number indicating how near a measurement or set of measurements is to an accepted value. So if I know that I'm taking someone's temperature and they're supposed to be 98.6, if I get 98.9, that's pretty accurate. If I get 102.5, ooh, that's not accurate at all. Either there's a problem with the subject, my person's boiling over with fever, or there's a problem with the way I'm using the instrument. So again, to take a look at my target that I'm trying to hit, here I'm being much more accurate, if you remember, than I was being before. I'm not really as precise though, am I? I'm not being very consistent. I'm either in the red, I'm in the yellow, I'm much closer to my estimated target where I want it to be, so I'm being much more accurate, but I'm not being precise. So accuracy and precision, although we tend to think of them as the same thing, they're really two very separate things. Accurate, how close you are to a designated number, your measurement is to a designated number. Precise, how consistent your measurements are. Accurate, the goal in a scientific measurement is to be both accurate and precise. Now, how can we tell how accurate or precise we are being? One thing we can do to determine the accuracy of our measurement is to determine the percent error. This is a number that indicates how accurate our measurement really is. If we're trying to reach a target number, we can compare what we're getting to that target number. So here I have the accepted number. In my example that I gave with a human temperature, it would be 98.6 minus the number that I got, 98.2, let's say, okay? Divided by the accepted number again. Now notice these are in parentheses here. So because of your calculators and order of operations, if you don't have a calculator that you can put parentheses in for, you would take these two numbers and subtract them. You would hit the equal sign, this minus this equals on your calculator before you hit the division. Else the order of operations will actually divide these two numbers and take your number minus 1, which is not necessarily going to give us the appropriate answer. Okay, we times it by 100 because the answer is given in a percent. Okay, so if the known value for the acceleration due to gravity on Earth is 9.81 meters per second squared, and you find a value in your lab to be 9.50 meters per second squared, what is the percent error of your measurement? So following this equation, I take the accepted 98.1 meters per second minus what I found in the lab, 9.50 meters per second squared, and then I divide that by the accepted again, 9.8 meters per second squared, and I'll take all of this times 100 to get my answer into a percent. So we do the math, we subtract these two numbers first, remember, then divide, order of operations in math, and I get a percent error when I take my number times 100 as 3.16%. Now, the lower the percent error number, the more accurate your measurement. So if this were 10.16, that would have more error in it than 3.16. We want a small percent error. So the measured percent error of my laboratory measurement has an accuracy of 3.16%. So the lower the number on the percent accuracy, the better. Now, we also have a number that we use to determine how precise our measurements are, and that's called a standard deviation. Now, at this point in your 9th grade career, you don't have the math, the statistics necessary to calculate and understand standard deviation, to understand the calculating. So I'm never going to have you calculate out the standard deviation like I did just now with the percent errors. But you do need to know, if I give you a number, what that number means. So the standard deviation is a number, just like percent error was a number that told me how accurate my measurement would be. The standard deviation is a number that indicates how precise our measurement is. A high number means I have a wide range of numbers present. So the higher my number, the less precise I am. The smaller my standard deviation means the closer my numbers are together and the more precise that they are. And again, you're not going to have to calculate that out like we did for percent error, but if I give you two numbers like a 0.5 and a 0.7, you should be able to tell me that the group that got 0.5 had a better precision than the group that got 0.7. in their standard deviation. So I'll always give you that number at this point. Okay?